Oh, what was it? Is it sine over cos?
It is 1 over sine.
So 1 over sine. Find x in terms of a. Okay. So then you can rewrite it as you multiply over this 1 over sine.
Yes, and actually a quick and easy way would be to say sine x is 1 over a.
Okay.
And so how would you get x?
So x equals sine over
Arc sine.
arc sine.
Okay. Yeah.
Why's it arc sine?
Like
Is it 'cause you...
sine to minus 1.
Yeah.
1 over a. Yes. There we go. Okay, so we did that. So try the middle and the right.
So sec is cos, which equals a. So cos x equals 1 over a.
Mm-hmm.
So x equals arc cos 1 over a.
Mm-hmm.
And then the last one is x equals arc cot 1 over a.
Arc what, sorry?
Arc cot tan.
Yes, that's it. And so the easy way of doing these is to just say that it's equal to the reciprocal of the thing that's on the other side. Okay, solve this equation. Okay, go on, solve it.
Sec x equals 2, 0, x, 2 pi. So you can do x is equal to arc sine half.
Mm-hmm.
And then you calculate that with brads.
So cos x is a half. So x is arc cos of a half, and then you just go from there.
Mm-hmm.
So I'm gonna. Okay, how about this
one? Cosec squared equals a. So you do sine squared x equals 1 over a.
Yep.
And then would you do sine x equals root 1 over a?
Yeah.
And then x equals arc sine root 1 over a.
And just watch out for the fact that it will be plus or minus.
Oh yeah.
Because it was originally squared 1 over a. So double the answers, double the fun. Okay, middle and right.
Okay, so the middle one will be cos x equals root 1 over a. So then x equals arc cos 1 over a, root 1 over a, and it's plus minus.
So go on, start again.
So cos x equals root 1 over a.
Something's missing. This is what you said for the left one. This is what you're saying for the right one.
Oh, so you put a squared in front of the...
Yeah.
Mm-hmm. So then you...
And then... yeah, sorry, go
on. So yeah, you continue with cos x equals root 1 over a, and then...
That's it. So you left out the root last time.
Okay.
Okay, one on the right.
So that is tan x equals root 1 over a.
Yeah. Wait, you left it out again?
Well, tan squared a.
Oh, sorry, you did it in one. Yeah.
Okay. Yeah.
Alright.
Equals 1 over a.
Okay.
So yeah, x equals arctan 1 over a.
Something's still missing.
Root 1 over a.
And something's still missing.
Plus minus.
Yes. And the plus minus happens there on the root. Okay. Let's see. So you've done that. Okay, let's try this.
Okay. So cot theta, cot squared theta equals 3. So theta equals cot. That is cos over sine, isn't it?
How do we solve cot squared x equals 8?
Which one is cos over sine? What's that called?
Well, that is technically what tan is, what cot is. So you can imagine, how would you? Let me just see this. 3. How would you solve this? Tan x is equal to 3.
So you do x equals arctan 3.
Yes. You would not do this. Sin x over cos x is equal to 3. That would be more complicated. Even though this is true.
Yeah. Okay. So for this one, you do theta is equal to arctan 3. The root of 1 over 3.
Yep.
Plus minus.
Yep.
And then from there, you solve for the positive and negative values of the root.
Go on, try it.
Okay. So I'll start with the positive. And I get a third pi. And then it repeats every 180 degrees with tan. So you just add pi to it.
Well done. So
that
theta
becomes
is equal to 1/3 pi. I think believe it'll be plus or minus, and then you'll just do those two answers, plus or minus pi 180.
Would the answer be plus minus a third pi, or is that just because it would give the same answer in the bracket?
It's just a short way of writing theta is equal to 1/3 pi, or theta is equal to negative a third pi.
Oh, I didn't realize that.
Yeah.
Doing the negative square root gives the same answer, but negative.
Yeah, I believe it is for tan.
Yeah.
So
okay.
You're right. That won't always happen. I think just in that instance.
Sure.
Let's see. Now I will go straight to your book here. So we did those. So that's just the recap. So I'll look at what the red ones look like. Let's see. And have you done these questions yourself?
No.
Okay.
This is from the disorganized part of the course. So yeah, no.
So I think you'll be fine for these ones. There's one there that you may have difficulty with. We haven't quite done it, but let me just see something. Let's just do the red.
Sure.
One of them is it just relies on an identity.
Okay.
Okay, so let's start with 6.
So 1 minus cos x 1 plus x equals sine x. So that, okay. I'm not too sure how to go about it.
What is sec x?
That is 1 over cos.
So 1 minus cos x, that's 1 plus 1 over cos x. And I think just go for it.
Equals sin x.
Yep.
Thanks. I'm still. Would I have to multiply for us? Expand.
Yeah.
Okay. So that's 1 plus 1 over cos.
Yeah. Hang on. Go on. Do that. See what you get.
Okay. Minus 1. So I get 1 plus 1 over cos x minus cos x minus 1 equals sin x.
Yeah. Before we do anything else, how would you do this question?
X minus 3b equals 0. I'm a bit stuck.
How would you do? How would you do that question?
I had to make it into a quadratic and solve it from there.
See, that's because you're. What if it was on a non-calculator paper?
Then I'd say that x is equal to 3.
Yes.
And x is equal to minus 3 over 3.
I believe that's that. And that's because you've done it so many times that you're skipping the middle step, which is to say either the first one is equal to 0 or the second one is equal to 0. So something times by something gives you 0. One of those numbers has to be 0.
Yeah. I actually never realised that.
So what would be step 1 for the tan one?
So you could say tan x minus root 3 equals 0, or the other one is equal to 0 too.
Yes. Equals 0. And now we go back to here. What's next?
Since it's equal to sin x, would we want to bring over the sin x?
Yep.
So would we do that before factorizing?
Yes, because technically it was already factorized.
Yeah. So we do 1 minus cos x, 1 plus 1 over cos x, all over sin x.
You're thinking of dividing everything by sin x, is it?
So then, yeah.
This is just sin x on the right side.
Will we subtract it?
Yep.
So minus sin x equals 0.
Yep.
So then we could say that 1 minus cos x, 1 plus 1 over cos x, or minus sin x equals 0. Yeah, minus sin x. So that gives you that first step.
What if I put them in a different order? Now what would you do?
Okay, so the ones would eliminate themselves.
Yep.
1 over cos x. Cos x. Sin x. Since all of these are different, would you have to rewrite some of them for something else?
There's two ways you can do it. One way is using the addition angle formulae, putting it in the sign of r sine theta plus alpha, something like that. The second way, the tricky part is the denominator.
Mm-hmm.
How,
Yeah.
how could you get rid of that?
You could multiply everything by cos x.
That would.
So you get 1 minus cos squared x minus sine x over cos.
Cos squared x minus. It would be times, wouldn't it? Sine x cos x.
Oh yeah, sine x cos x.
0. Then what?
Could you factorize it again?
I think so. That actually needs some. 1 minus cos squared x requires an identity.
So that could just be sine x.
Hang on. It's sine squared x.
Minus sine squared x.
Positive sine squared x, I believe. So, you know this identity, so this is the one you'll use a lot. Sine squared x plus cos squared x
equals 1. Yeah, I was just thinking about how to rearrange it. Yeah.
If you bring the cos squared x to the right side.
Yeah. Then it's minus. Yeah.
You get that exactly.
Okay, so sine squared x minus sine x equals 0. So then from here you could factorize it if needs be.
Yes.
So sine x brackets minus 1 cos sine x then 1 sine x minus cos x equals 0. So then you can say that either sine x equals 0 or or sine x minus cos x equals 0.
Yes, and so you then have two simple things that can be solved.
How would you solve it?
So first one is easy peasy, sine x equals 0. You're okay for that one?
Oh, so just arc sine 0.
Yeah.
Okay.
Second one, I believe you can divide through by cos. What would happen if you divided everything by cos x?
So then you get tan x minus 1 equals 0.
And so tan equals?
So tan x equals 1 equals 0. So tan x equals 1.
Yeah.
And then you'd rearrange to get it.
And then you would just do arctan, etc. So the trick for these is fully expand, make it equal to 0, fully factorize, and then solve. The difficulty is that it involves identities. So noticing that 1 minus cos squared x is the same as sine squared x. And the other thing is, like, there has to be a way to solve it, and so you can kind of look for, well, what way can it be solved?
Yeah.
So with that in mind, try 7.
Okay. To solve cos theta. So cos theta is 1 plus theta, so cos is 1 over sine theta equals 1 plus what am I saying? Cos theta equals 1 plus 1 over sine theta.
One over what, sorry?
1 over cos theta.
Yeah.
Okay, so you could bring over the 1. Or you could bring over the cos
Sure.
and make it equal to 0. So 1 plus 1 over cos theta minus cos theta equals 0. And then multiply everything by cos theta. So you get cos theta plus cos plus 1 minus cos square theta equals 0. And then you have a quadratic there.
Yeah. And you can put that into your solver. You get 2 answers, and you go from there. Yeah.
And with those answers, you just extrapolate it along the curve, right?
I mean, you would just... So, let's take a look. So, where are we? Number 9. This one. Polynomial, degree 2. Minus 1, 1, 1. There we go. So, we get cos theta is equal to 1 plus root 5 over 2, or cos theta is equal to 1 minus root 5 over 2, and you would just solve them usual way. Arc cos. You might get a decimal, but nothing new about that. Let's see. And then question. Any questions there?
No, I'm just figuring it out for myself on my calculator.
Okay.
Just type it in. I get pretty massive numbers.
So if I press SD, so that was that.
Do you just plug in minus 1, 1, and plus 1?
That's what I did. Minus 1,
Okay.
1, and 1. Yeah.
No, it's because I used the solve in the matrix, so it isn't exactly suited. But yeah, it's fine. I understand.
Okay. And is 8 worth doing? Similar idea.
Sure. Yeah.
Okay. Go for it.
So cosec squared over cosec squared theta equals cos theta. Okay, so we want to get cos squared theta. So cosec is 1 over sine squared theta minus 1 over 1 over sine squared theta minus 1. Just could that be rewritten as 1 over sine squared theta minus 1 plus sine squared theta? Because it's bring it up.
So, I think I'll be able to save you a huge amount of time. It's the difference of 2 squares, I believe. So what would it be? Like x squared minus 1. What would that be in 2 brackets?
X plus 1, x minus 1.
Yes. And so this is the same thing. Cosec minus 1, cosec plus 1. Now I don't know if that's actually going to help us, but maybe it will.
Okay.
And actually, cosec squared theta, what is that the same as?
Cosec squared theta is the same as 1 over sine squared theta.
Yes, and because it's on the bottom, that can be brought to the top.
Yeah, exactly.
Is equal to cos squared theta. Show that. Oh, it's identical to cos squared theta. It's identical to cos squared theta. And what is cosec the same as?
Cosec is 1 over sine theta.
Sine Okay, what do you get there?
Um, would you have to multiply them all together? That seems a bit long.
Let's see. What if you multiplied one of them by sine squared theta? Let's say the
Um,
second bracket.
So then you'd get sine squared theta plus sine, just sine
Sine
theta.
theta, yep. Okay. And then you would just have to expand those.
So what so again, so sine squared theta minus sine squared, just sine theta minus sine theta plus 1. So it's in fact minus sine squared theta plus sine theta minus sine theta plus 1. Yeah.
And can that be simplified?
So it can be put as minus sine squared theta plus 1.
Yep.
And which is equal to cos squared theta.
Yes, cos squared theta. And then hence solve. How do you hence solve?
So we could say, I'm not too sure.
Hence?
So we'd use what we found, so cos squared theta, but I'm not absolutely sure.
So that whole weird thing is the same as cos squared theta.
Right, yeah.
What's the spot the difference between top and the bottom?
Well, the fact that one has 4 cosec squared theta minus 4, and cos squared theta is equal to 3.
And so
would you write something like cos squared theta equals 3?
it's something a lot like that. What about that 4 thing though?
Well, that's what I'm confused about.
4 cos squared theta equals 3. If you factorize out the 4, you get the same thing as above. Basically, they multiplied it by 4.
Oh, I see.
Yeah, and if you're ever not sure, just monkey around with it so it's identical to the thing above it.
Okay.
From the previous one. Yes, any questions there?
No.
Okay, so that is the trickiest stuff for that one. If you want, these are identities. If you want, we can do some composite stuff.
Yeah.
Okay. Composite functions. Composite functions. Let's just cut the brass tacks. Look at this wonderful lesson plan. Nah, let's just... You said you wanted the tricky stuff, so I'll stick with this one. Number 4, functions, composite. Composite function. What are composite functions?
Something that I haven't done in a long time.
Two functions, and you put them, two or more, and you put them together.
In, so like, okay. Well,
Here's your sketch. Oh, that's not really composite functions. Let's just see this. Yeah, find the expression. That's inverse functions. Yes. Okay, we'll just go for hard instead of hard. We can do both. Let's go from there. Let's do part 3. How would you do part 3?
for find the expression for g of x or f g x. This is what is meant by composite functions. Oh yeah. So you just substitute in f of x for x in g of x for the first part.
Yep. What do you get?
So for the first one, you get 2 brackets x squared close brackets minus 1.
Mm-hmm.
So yeah, that's the first bit, and then the second bit is f g of x, so it's 2x minus 1 all squared.
Mm-hmm. And then how would you solve that equation?
You'd equate them to each other to make them
Yes.
equal to each other.
And then you just solve the normal way?
Sorry?
And then you just solve the normal way?
Can I solve them another way?
And then you would just, like, would you be confident in solving this?
I would divide to the right hand side. Would you do the square first to try and get rid of that first?
Yeah.
Or actually multiply out the left hand side, so 2x squared minus 1.
Mm-hmm.
And then the right hand side would be 4x squared minus 4x plus 1, or something like that.
Yep.
And then you would, make it equal to 0, and it would be a quadratic.
Yeah, and just go from there.
If it's a quadratic, and it has, if you do it as a quadratic, it will show the roots, right? So if you draw it on a calculator or whatever, would they intercept at the x value of where these two are equal to?
Yeah.
Okay.
So that's where they cross over. So yes, you're right about that. And then find the range of values for A. Did we do A? No, we didn't see it. Let me just see. So there's some inverse functions, and I think so. Finding the domain and range is trivial if you use your calculator.
So the domain and range is just the values at which they go up to in the x and y direction, right?
Yeah.
Okay.
So I think we have to look at inverse functions. Let me just see. So let me go back to this one. State the ranges and explain why the f of x has no inverse. What is part 2?
Okay, so you would just do 1 over 2x minus 1.
Okay. So g inverse of x. Say it again, sorry?
Would you do 1 over 2x minus 1?
You're thinking of reciprocal. Inverse.
Is that where you flip the x and the y's?
Yeah, go for it.
But why is it that how do you know when it asks you for a reciprocal or a reflection? Due to the fact that they both use minus 1.
Reciprocal doesn't use minus 1, to only inverse.
So if you were to do, say, like x to the minus 1, that could also be written as 1 over x.
Oh, okay. I see what you're saying. So it's like sine to the minus 1 on the calculator. That's arcsine.
Yeah, so,
That is not what. That is not.
oh, that's not 1 over
That's not
sine.
cosec. Yeah.
Yeah, that's confusing.
So it's
Okay,
not. It's not. It's not a power. It's not. It's not equal to sine x to the minus 1 or something like that.
so it's only when you're using actual values or brackets that does that?
Yeah. I mean that would be confusing if they were to do it, but yeah. So it would be like the whole thing sine x, the whole thing to the power of minus 1
Hmm.
is cosec x 1 over sine x,
Okay, understood.
and that's kind of why they put it in there. Yeah.
Got it. Okay, so find an expression for it. So you would do the inverse. So you would make it y is equal to 2x minus 1. So you would do 2x equals 1. And then, so y plus 1 equals 2x. And then you would do y plus 1 over 2 equals x.
Yeah.
Can you believe that it took my teacher a whole 2 lessons to make us understand the concept?
One last thing you need to do.
Sketch the graphs of y equals 2x.
No. You have to swap them back and do a little extra thing.
Okay, so y equals x plus 1 over 2.
Yes, and they would accept that 1 over 2, and that is now, instead of the f of x, it's now the inverse function, f to the minus 1x.
Okay.
Yes. What they don't accept is f of x equals, because it's not f of x.
No.
However, if you write y equals, I believe they accept that. Well, they have on the exam papers that I was marking, but here I don't see any y equals, so
Yeah.
we'll just be safe.
Okay. Are you an examiner? Like a...
Yeah.
Yeah, okay.
Unfortunately, I marked those exam papers.
If you see mine, help me.
I get stuff from like North England. They do that.
Fair enough.
And I mean, I don't even look at the names. It's just get through them quickly.
Yeah.
So that was 13. And I think you're mostly okay for inverse functions. That was that red. So this one is just, you put it in completed square form, and that helps you to sketch the graph. But sketching the graph is easy to main range. Okay. Let me just go up to the other functions. The red question there. If there are, yeah. Okay, this one. Okay. Okay, question 16. How about that?
Sketch this. In which they are used, yeah. This is something that we also struggled with. I don't know the order in which they go. Would you do the normal translation, so like left, right?
Bidmus.
Okay. So you would do the minus x squared first?
So, yeah, x squared became minus x squared. So, what happened there?
So you multiplied it by minus 1. I don't know what that means for the graph though. It gets stretched in the parallel to the x direction. That's scale factor 1.
Yeah, and there's
Minus 1.
And there's a very special type of stretch if you stretch it by minus 1. That's called a reflection.
Yeah.
And if it's parallel to the x-axis, then that's a reflection in the
Y-axis.
y-axis. Yeah. in the x direction in the y-axis.
Mm-hmm.
Okay, so then minus x squared, what's next?
So then 2x.
Wow, here's the sketch. This. You could do both at the same time. Like, let's just say, so that becomes minus x squared plus 2x minus 1.
Mm-hmm.
And so what is that?
Plus 2 minus 1. So that is a stretch with scale factor of a half.
A stretch is if you're multiplying or dividing. This was just adding and subtracting.
But isn't it 2x though?
Well, there was no x before. Oh, hang on. Specify the transformations in the order in which they are used. Yes. What about the minus 1?
The minus 1 is just the c coordinate.
Mm-hmm.
And it's moved down by minus 1.
And so that would be a translation.
Yeah.
Translation. But as far as I can see, so the vector for that would be 0 and 2x minus 1. But it has an x in it.
Yeah.
That's hella unusual. I have to look that up. This is chapter 4. Mm, 19. Chapter 4. What is this? Chapter 1, chapter 2, chapter 4. And this was question 16. 14, 15, 16. So it's a reflection in the x-axis. That was a reflection in the x-axis. Why is that? So this is this is real tricky. Let me just see something. And then translation 1, 0 in either this direction. That's hella crazy. That's a red one. I'm going to leave that red one for a moment. Hang on. Just want to see what these things are made of. I want to see this one. Write down the equation of this thing. See, this is crazy stuff. Hang on. Let me just get a slightly more normal one. Before we go crazy. Write the expression. Oh, I see. So the way to do it is we had to factorize it first.
We had to factorize it.
Yes. We had to put it into completed square form. So if we take out the minus, and it becomes minus x squared, x squared minus 2x plus 1. So what is that in completed square form?
Oh, so you do x minus 2x over 1 squared plus 1.
Mm-hmm.
No, plus the squared. No, okay. Minus 1 plus 1.
And then plus 1. Will it make any difference? Plus 1.
Yeah.
Won't make any difference, I don't think. Yep. And so, so it's just minus x minus 1 squared. Yes. And so, what? So the x didn't change. So you basically had x squared and let's just put that in a bracket, x squared, and that became, well, let's say, yeah, negative x minus 1 squared. And so the negative is not next to the x, so it's in the y direction, so the x-axis. And x became x plus 1. So what is that?
So x became x plus 1. So it's a translation to the left in the x direction.
Translation to the right.
X, but isn't plus 1 and you do the opposite?
This is minus 1.
Oh, sorry. I thought of plus 1. Yeah.
And so that's 1, 0. Yes. So let's just do the one before it. So the one before kind of spells it out a little bit more. Okay. 15. Yeah, how do you do that?
15. So write the expression x squared minus 6 in the form with a are numbers which are to find. So you do it in completed square form. So that is x minus 3 squared plus minus 9 plus 14, I believe. Yeah. So then that is just x minus 3 squared plus 5.
And then what transformation maps x squared onto that?
Okay, so it's a translation of plus 5 being the plus 5 of the y-intercept going up, the plus 5, and the x value is going 3 to the right.
Yes, that's it. So it's a translation 3, 5. So the previous one wasn't more difficult because it had 2 transformations. It was more difficult because I didn't think of it easier to put it into completed square form and to complete that way. But that is all of the hardest questions for chapters 4 and 6.
Yeah.
So the trig stuff, yes, fully expand, make it equal to 0, fully factorize, and then solve like separately. Just go over the identities, the reciprocal trig stuff for solving. It's easier to break them down, like make them 1 over sine, that stuff. And then functions, there's lots of sketching for domain and range, which isn't too bad. But then composite, putting them together, inverse, you're okay. And then transformations, complete square.
Okay.
How was that for you, Gregoire?
That was good. Thank you very much.
Anything in particular you want to do next time? Do you know?
I was thinking maybe to have another session on Wednesday.
Yeah.
On your event.
Let me just look at my calendar. Wednesday.